are in listen-only mode.
Greetings, everyone. This is Mark Albert, Editor-in-Chief of Modern Machine Shop Magazine. Welcome to our webinar sponsored by Modern Machine Shop and TCI Precision Metals. Thank you for joining us. Our topic this afternoon is productivity gains with machine-ready blanks. As most of you know, job shops and manufacturers are facing potential operational pitfalls today, including throughput challenges, machining efficiency, controlling cost, and a lot more. This webinar will show how custom and standard machine-ready blanks can help a machine shop meet these challenges and become a truly lean operation. Our presenter today is John Belzer, President, TCI Precision Metals. He will discuss processes and material sourcing designed to help shops be more competitive and profitable. John will cover a number of practical applications to give shops the knowledge and tools to effectively increase throughput while reducing waste and overall costs. As we listen to John and follow along with his presentation, please feel free to share your questions with us by typing them in the questions pane on your control panel. John will answer those questions at the end of his presentation. Keep in mind this webinar is being recorded, so you will be able to view the entire program online later. So thanks again for taking time today to be with us for the live program. Here's John.
Thank you, Mark, for your introduction. As Mark mentioned, I'm John Belzer, President of TCI Precision Metals in Gardena, California, which is just a few miles south of downtown Los Angeles. In Gardena, we have 105,000 square feet of warehouse and manufacturing space, and we've been around here for 55 years. It's hard to believe sometimes that I've been in the business over 40 years. I don't know if that means I'm experienced or just old. But I'm a second-generation owner with a third generation, my son Ben, in the business as well. This is the only facility we have, but we regularly ship parts daily to customers as far away as Burlington, Vermont, Norfolk, Virginia, Houston, Texas, Boston, Chicago. You can probably name your location, and we've shipped there. We evolved over a long period of time from rough and precision sawing into duplex milling and blanched and double disc grinding in response to our customers' needs and expectations. Once upon a time in the 60s, precision sawing was a real high-tech process. But over time, sawing didn't answer customers' problems, and we needed a better way to provide a more close tolerance part that was easily made square. So we're a value-added distributor, and that's to say 100% of the product that we ship has either been sawed, ground, duplex milled, flattened, deburred, what have you, and absolutely nothing leaves our facility looking the same way that it arrived. We're not in the business of what I call straight distribution, and that's just raw stock with no added value. Although we're an Alcoa distributor and a distributor for Kaiser Aluminum and Hulamin, again, nothing goes out the back door without adding value to it. We've been a member of the NTMA for 35 years, and I mentioned the NTMA as I think it's been one of the best resources ever for learning, growing, and improving our business. The members who are actively involved locally and nationally in the NTMA are among the brightest people that I know in the industry. In addition to the above, I also served for 6 years as a trustee for our Los Angeles NTMA training centers here in LA. We have 2 schools with a total of 525 students on campus, graduating a class just about every 6 weeks. And I tell you all of this only because it just gives you an idea that I've been in the industry for a while, and I think that having been around the country as the chairman of NTMA, I've had that opportunity to see hundreds of shops and understand what our shops owners have difficulties with. And by the way, while I think of it, we have a close relationship with Boston Centerless in Boston, Massachusetts, who does essentially what we do, but they do it in close tolerance seroless ground stock as opposed to flat work, which is what we're mostly involved with. So let's get to the situation. These are just some of the pressures on our industry. We've been seeing an increase in activity in our industry since the 2008-2009 downturn, call it what you will, domestically, with fewer shops left to handle the load. Recently, a weak dollar has at least temporarily given us a boost in making U.S. manufacturing more competitive. And although most of the information that we hear in the industry may be anecdotal, I think it's becoming more common that manufacturing that has been offshored in the past is beginning to be reshored. And for more on this topic, I'd encourage you to visit the Reshoring Initiative at www.reshorenow.org. It's all about the effort to bring manufacturing back home. We're a sponsor of the organization, as is Gardner Publications, and I really believe that it's in all our best interest to do what we can with our customers to make reshoring happen. Customer expectations are high, and it's more frequently difficult to meet them. Quality is a given. Over the past few years, we've seen everything from reverse auctions, customer-driven top-down changes in terms and conditions. We just received one today. And target pricing. Customers continue to demand faster, more frequent deliveries as they try to reduce their own inventory levels to lean out their operations. And they may tell you that price isn't always that important. Eventually, it always is. And understandably, the customer really doesn't care what your internal issues are. They just want good parts on time. Skilled labor is in short supply. We all know that we've done a pretty poor job of addressing the needs of American manufacturing in the educational system nationwide. Due to the gutting of vocational education from public school systems and counselors and other administrators insisting that all students be college-tracked, we're left with a severe shortage of skilled machinists, programmers, engineers, inspectors, etc. We need to fill the workforce development pipeline. If I learned anything at the recent NTMA Fall Conference in Colorado Springs a couple of weeks ago, is that this is a nationwide problem. It's not just here. In the meanwhile, we all need to match our human resources with our need to satisfy customers' demands. I mentioned just a few minutes ago what the NTMA Training Centers is doing to solve the problem. And backlogs are on the increase, and I think that many shops are pushing capacity levels. We all want to take on more work, even when backlogs are increasing. After all, it's about throughput. How much can we push out the back door without severely impacting the different parts of our businesses? But how do we do that given all the constraints running a business profitably? So here are some of our challenges. All four of the points on this slide are linked and can't easily be separated from each other. Successfully managing customers' expectations should ultimately make our companies better and more profitable. Increasing throughput in its simplest form is moving more work through your shop without significantly increasing the cost to do it. Sometimes it can be done internally through creating work cells designed around a product or a family of parts that use essentially the same machining disciplines. Sometimes it requires finding external solutions to streamline the flow of raw materials or parts so that as little time is wasted on the shop floor getting the next job up and running. I think it's understood that quality must be maintained or improved over time. After all, if you're an ISO 9001 or AS 9100 certified supplier like we are, you're going to have corrective actions to adjust if you're not meeting or exceeding your own specific quality goals. As for increasing your company's margins, you'll see in this presentation that reducing costs, especially on raw materials, may not be a simple matter of finding the cheapest supplier of what other inputs you have to your operation. Many times it seems like it's just getting 3 quotes for raw stock and driving that price down and finding the cheapest supplier. But there are ways to be creative about the pre-production stage, especially when you have a supplier who can economically reduce the incidence of attrition on the front end and present cost savings opportunities in your shop as a result. And the last piece is implementing new ideas for raw material purchasing, decreasing run times, and increasing throughput on the shop floor, all without substantially increasing any cost at all. That's where machine-ready blanks comes in. This slide depicts how we traditionally think about how shops are run, with the assumed goal of satisfying customer needs over on the left in blue. I think that satisfying customer needs and helping them solve problems is what we're all about, and that's how we're singled out and we're more competitive against the next person. It's a pretty normal way to do business. Most shops reasonably consider their core competency as machining, and most shops continue the time-honored practice of purchasing raw materials oversized at the beginning of the cycle. When the raw stock arrives, if it hasn't been drop shipped to a heat treater or grinding shop for a first operation, it's either staged for the prep work necessary to finish machine, or it's machined to size as part of the finished machining process. Typically, there are other outside processing ops that need to be performed. They're not part of a shop's core competencies. What we're faced with here is a classic batch and queue system. Few of the steps are being performed simultaneously. The way I look at it, when raw stock hits the floor, it should not be taking a vacation before it gets onto a machine. The end result, I believe, is that batch and queue doesn't serve our customers' interests as it slows down the pipeline of finished parts to them. There's a better way to increase the velocity of parts on the shop floor. This slide shows a different way of getting to the important work of providing your customer with a finished machine component. The blue circle in the lower left depicts the job planning and purchasing stage, a very traditional way of buying raw stock. With incoming raw stock, material either needs to be prepped prior to final machining, or it's machined one side at a time as part of the finished machining process. Either way, it's more time-consuming and more costly than it needs to be, never mind that it uses up valuable machine time on a CNC. The alternative shown, very simply, in the rectangular box down to the right, brings raw materials to the machine, actually ready to finish machine, a better use of any machining center's value. The machine-ready blanks arrive to your exact specifications, your tolerances, your flatness, your squareness, and with a good surface finish. In-house machining time is reduced. Better yet, it was all done ahead of time while your machine was already working on the previous job. That's becoming more lean. The result? There's faster throughput on the shop floor. It creates more time available for more work. There's less WIP inventory, since the machine-ready blank goes directly into production. There's a shorter AP cycle, accounts payable. There's a quicker invoice to your customer because you've got better throughput. And finally, there's an accelerated payment to you, and that's what it's all about. So here are 3 examples that we'll walk through. First, in this example, here's the job being machined from raw stock. It's about 1/8 of an inch oversized in all directions with enough stock to clean up. So in our example, the prep time, or time in the shop CNC program to face all sides of the part while machining, runs over 11 minutes. There are 15 minutes in the part to load, unload, change clamps and fixtures. The finished machining time runs almost 55 minutes for a total of 81 minutes per part. And by the way, this isn't a hypothetical example. This is a recent actual job from one of our customers. So when we supplied a machine-ready blank instead, here is the first result. We have a part that is not oversized, but it's exact to the customer's specifications. It's 0.625 by 9,700 by 16,250. It's plus or minus 1 on the thickness, plus or minus 2 on the width and length. It's flat within 2, and it's got a great surface finish, ready to finish machine. in our example, and that was the size of the order, there were 100 parts. So for the shop, there was no internal prep work going on, 0 minutes, no operator intervention, and no runtime to get that part ready. So the customer ordered to his exact net specs with very reasonable tolerances on all 3 dimensions. In fact, as I recall, the tolerances spec were closer than the print requirements. The parts, of course, arrived vacuum packaged, clean, with no oil or chips, ready to finish machine. And the CNC operators were able to load parts with no fixture or tool offsets. So the customer had no prep time, no unnecessary machining of outside surfaces, and that made the CNC program leaner. And finally, here's the finished machine part. Now let's understand that the part that you're seeing over to the right is a simple graphic representation of the part that was actually made by the customer. It doesn't really do justice. There were 3 different ops of machining that required 25 tools to make this finished machine part. So the end result, no prep time and no operator intervention, and no unnecessary changing of clamps. The total run time was reduced to just under 55 minutes. There was better machine utilization and better throughput in his shop, and more was shipped out the back door in less time. The trade-off is paying a bit more for a machine-ready blank. While paying about $30 more for the blanks over the cost of raw stock, $40 per part in machine time was saved, which is a net saving in hard cost of $10 a part. And of course, for 100 parts, there's $1,000 saved. More importantly, on top of that, the increase in throughput, freeing up 43 hours of machine time, created more shop capacity and the ability to take on more work with no increase in payroll. So the entire savings on this job, assuming that another job is coming right in behind it, allows a shop to essentially increase capacity for more work on that machine by 1 full week. Here's a second example. The prep work is this is a rectangular part, and I'm going to describe this as a generic rectangular part. The part in the box can be just about any size you'd like it to be. It could be 1 inch by 3 by 12 inches. It could be 2 by 6 by 30 inches. It could be 5 by 18 by 10 feet long. Our equipment can handle the small and the large. So when ordered as rectangular raw stock, as shown in this slide, either batch and queue prep work is going to be required prior to finished machining, or the faces and features will be added to the cycle time of the finished part. Either way, more time is being spent than necessary. It's an inefficient use of an operator's time, and the machining cycle is longer than it needs to be. So here's that same machine-ready blank with the cutouts made. We'll call those notches or steps. So with our duplex milling, we can machine all 6 sides of the rectangular machine-ready blank in 3 short setups, holding tolerances of plus or minus 1 or 2. The opposing steps can be machined at the same time on a duplex mill in 1 setup. In a typical shop, again, the part either has prep work prior to finished machining, or the faces are machined 1 at a time in the finished machining cycle. And the steps or notches have to be cut 1 at a time. The savings in time and money are reflected in the reduced cost and price of the machine-ready blank. Since we're cutting at least 2 sizes apart at the same time, the machine-ready blank user benefits from a cost standpoint. It is more competitive in the shop using raw stock. When the machine-ready blanks arrive with additional features added, less in-house machine time is required. Better throughput means more dollars are shipped in the same amount of time, and capacity is made available for taking on more work while having no increase in payroll. And it makes the user more competitive, more profitable, maybe even both. So let's go to our third example, and it's a little more creative. In this application, our customer needed to machine flats on a turned spherical shape. The diameter was approximately 4 inches, and the parts are about 15 inches long. So after machining from our customer, it came in weighing close to 50 pounds in here. Machining the flats one side at a time would have been a very slow process for the customer. It was an unproductive use of resources, both people and equipment, and I think that we probably all know that cutting 13/8 can be pretty expensive. The solution? Because of our specialty in duplex milling, milling 2 sides at a time, we reduced the cutting time to a fraction of what it would take in his shop. End costs are reduced by not having to buy additional expensive cutting tools or inserts, and the throughput was increased on the customer's floor. Since our specialty as a metal service center has always been providing value-added blanks or machine-ready blanks, we've built our business around equipment that is exclusively designed for that purpose. In the left-hand photo is a photo of a double disc grinder, a 42-inch Gardner double disc. In the center photo are a couple of 60-inch Blanchard grinders. And on the right is a New Century duplex mill that has, I believe, capabilities of opening up to about 29 inches wide. It's got 10 feet of travel. It's got a rise and fall on both heads, and it regularly duplex mills very large parts. So we can handle on all 3 types of machines very small parts and very large parts. We have 5 Blanchards, 8 double disc grinders, and 14 duplex mills that do the work. We've also been through a rather rigorous process here over the last 10 years or so of lean, and we've been creating work cells designed for families or light configurations. So we have cells for smaller and larger aluminum-only blanks, and we have cells set up for ferrous-only grinding and milling, and we have cells for ferrous-only duplex milling. I think that velocity on our shop floors is what it's all about. When we increase the velocity of parts through our shops, we ship out more product in the same period of time. If we decrease velocity through the traditional batch and queue system, we will always get what we always got. So I'd say first concentrate on core competencies, finding the best and highest use of time and resources. And that's keeping what your shop does what it does best and most efficiently. When I think of velocity, I think of freeing up time on the shop floor for better uses. I think of reducing constraints that prevent us from shipping more product, and identifying underutilized capacity and putting it to better use. Utilizing trusted suppliers, such as TCI Precision Metals, to help accelerate work to your shop is important. Using machine-ready blanks, with or without specialized features, I think is a very cost-effective solution. Improve your backlog by offloading unnecessary prep work and second ops. Better productivity and throughput means increasing your shop's capacity without adding unnecessary costs, such as payroll. And I don't think that anything will make your customer happier than good parts on time, except maybe for that old price thing. So our final slide simply reinforces what I've talked about in this webinar, concentrating on your core competency, which is usually close tolerance precision machining, not doing the prep work. Taking the purchase of raw materials to another level and getting the planners involved. Consolidating raw material purchasing, outside processing, and prep work into one function and one purchase order. There is a small premium to pay on the front end, but much more importantly, there's an operational reward on your shop floor and a financial reward on the back end by cutting costs, creating better throughput, and shipping more product. I want to thank all of you for taking the time today out of your busy schedules and joining our webinar today. I know you've got lots of options. We're all very busy. I thank you for taking this one. And if there are any questions, I'll do my best to answer them for you. In the meanwhile, please feel free to contact me if you have questions offline or you'd like some cost comparisons on your next job.
Okay, thanks, John. That was great. Really, an interesting and informative presentation. We do have a couple questions here that we want to get to, so we'll get started with those. In the meantime, I do want to remind our audience that they should feel free to submit additional questions by typing them into the question pane on your control panel at the right of the screen. And then we'll get answers for all of the questions, even if we don't get to them while we're on the air, but I think we're probably going to be able to handle that this time. And remember, this webinar is being recorded and will be available online. So if you can't stay for the whole session, you can catch up later. So let's jump in on some of these questions. First one, hey John, says, I am in the Midwest. How can it be economical for me to work with TCI in California?
That's a pretty good question. I hear that a lot when I travel the country, especially doing trade shows. So much so that I recall a time when I had a trade show booth with the masthead up on the top. It gave our location. People would look at it and walk away. The reason that we can be competitive, whether it's in the Midwest or anywhere else, is that we do something that pretty much nobody else does, or at least not to the extent that we do it. What we do is we machine or grind, again, 2 sides at a time, when in any conventional machine shop, you're only able to machine 1 side at a time. On top of that, as you can picture, we can let's take that first example that I had up there. We would double disc grind the thickness of that part from 3/4 down to 5/8 plus or minus 1. But then on the width and length, we can stack those parts and machine, let's say 2, 3, 4, 5 at a time. And so while the conventional way to machine that part would be 1 side at a time in your typical shop, we can make that part, we can machine that part doing anywhere from 2 sides at a time to, let's say, 12 sides at a time. And there's nobody in the country, in any shop, that can compete economically cutting 12 sides of a part at one time. And also, by the way, just as an added benefit, when you machine all those parts at the same time, they are identical when they arrive in your shop. And so it makes machining that part to the final configuration far easier. People do ask me about freight, especially to places like the Midwest or the East Coast, and when it comes right down to it, freight is such a small portion of the price of the part. It's almost insignificant. We're talking about 1% or so. So I hope that answers the question. You know, we have somebody in here in the office in our end, in the sales side, at 5:30 a.m. Pacific. So we're available for the East Coast at 8:30, for the Midwest at 7:30. So it's just like calling around the block.
Okay, thanks, John. So what materials do you work with or not work with? You know, what's the range of material types you can provide?
Well, the easy one is what we can't work with. And I'll say just very quickly, once upon a time, we burned down half the company. This goes back to the 60s, mid-60s, cutting magnesium. And so I can't spell magnesium. We don't do any magnesium, haven't done magnesium since. But we regularly work in, of course, aluminum, all alloys of stainless, aircraft alloys, brass, copper, pretty much any ferrous or non-ferrous material, including, by the way, titanium, Inconel, and some of the other exotics. So the type of material isn't an issue here. If we don't have it in stock, since we're in Los Angeles, we have a cafeteria of companies, distributors that we can go to find the right material.
Okay. Good. This question is, my only concern that if you save on shop time on the prep processes, but those processes are not the constraint, then we really haven't gained any capacity. Do you see what what we're looking for here?
I'm not quite sure what the question is.
Okay. Well, again, we're looking for a gain in throughput or part velocity. So I'm thinking here, if the prep process aren't holding you up, what's the gain for?
Did you say the print processes?
Prep process.
Oh, I'm very sorry. Prep processes. Okay. If the prep processes aren't holding you up,
right.
I don't mean to be impertinent, but my suggestion would be prep processes usually do hold you up. And the way I might suggest the way to answer that question is, I'm going to guess that very few shops buy machine tools, CNC verticals or CNC horizontals, for the purpose of doing prep work. I once got in trouble for calling it idiot work, and I said, well, that's what we do. You shouldn't be doing it. But I would challenge the shop owner that, or the shop manager, that those machines were not designed to do prep work. They're designed to do far more close tolerance precision work than doing prep work.
Okay, I think that's the answer we're looking for. John, what is your typical lead time for blanks then?
Well, I guess that depends. It depends upon the quantity, perhaps, and on the size of the part, perhaps. These days, our typical lead time on small quantities is probably, I'm going to say 4 days, 5 days. The typical job ships out of here in less than a week and a half. But it all depends on what the material is and what the quantity is. That said, I think that one of the questions that we should ask the most of a customer is, when do you need the part? And then we'll do our best to fit that into the customer's schedule. But typically, we're talking about less than a week to 2 weeks, depending upon the quantity.
Okay. Question here is, how do you prevent contamination of stainless with iron on machines that also cut non-stainless steels?
Well, if we're talking about double disc grinding, and that's where you might find the contamination, I don't think that we would find any kind of contamination on a duplex mill. It's a very different operation, and every machine gets cleaned before you change alloys, especially on a duplex mill. That shouldn't be a problem. The issue might be on the double disc grinding side, where you are using flood coolant on different alloys. We have a 5,000-gallon central tank in our grinding department, and all of that coolant goes from the grinder into the tank, gets the swarf is separated, the coolant goes back to the machine as clean as possible, gets recycled through, and so every time you're working on a part, you're dealing constantly with fresh, more or less fresh coolant. I can't think of a case, and I would tell the participant, if I could, if there was a case where we had a problem with a piece of stainless or a stainless part being contaminated by a non-stainless alloy, but I can't think of one.
Okay. Do your engineers regularly work with customers' engineers to come up with good processes? Do you make suggestions that our engineers may not see, I guess, in terms of process improvements?
Well, that's a really good question. It really speaks to the other side of our business, which we didn't talk about today. On the machine-ready blank side of our business, I don't think that we deal a lot in terms of engineering. It may be so. There may be some suggestions from our inside salespeople as to how to better make that part as a machine-ready blank. And I guess what the participant needs to know is our inside salespeople have been around here, seems like almost as long as I have, but but they've been around here anywhere from 14, 17 years. So they've been in the business an awful long time and understand how to make a blank. So to that extent, the engineers do get involved. The salespeople do get involved as kind of quasi-engineers in helping the customer make that part the best way.
Okay. Do you have any other locations beyond Gardena, California?
Well, no, it's been suggested by a number of people, especially on the East Coast, that maybe we ought to open up another shop on the East Coast. And I've for one reason or another, I've resisted doing that. But no, this is our only location. We're in Southern California, in the Los Angeles area. I don't think it's been an impediment to shipping around the country. Although most people think that California may fall off the earth pretty soon, or kind of off the continent pretty soon. But no, this is our only location.
Okay. This is an interesting question. Do you have the ability to stagger shipments to support JIT manufacturing, that's just-in-time manufacturing?
Absolutely. Actually, there are customers who call it JIT. There are customers who call it vendor managed inventory. There are lots of different names for doing that kind of thing. Yes, we do. We have, for any number of customers at any one time, a fair amount of finished goods on the shelf. So, for instance, you don't have to place, if you need 100 parts during the year, you don't need to order 100 parts and then have all that inventory sitting on your floor. We're happy to deal with 100-part orders, schedule the shipments out during the year, and ship them out a day or two before the customer needs them. As for an actual Kanban system, we do have a couple of customers that use a kind of a form of Kanban. Everybody uses it a little bit differently, but I guess the big answer to the question is yes, we'll handle that issue, whether it's vendor managed inventory, JIT, or Kanban.
Okay. Do you keep up with advances in metallurgy or materials development, what's coming from the mills?
Honestly, I would have to probably say no. Most of the time what we do here is, in fact, I would say pretty much all the time what we do here is we build to print. So we build that machine-ready blank to print. And we don't get into suggesting current available alloys or future available alloys to the customer, unless it's something very, very obvious. We pretty much build it to print. The only side of the industry that I might keep up a little bit better on in terms of future alloys is on the aluminum side. But frankly, most of those advances in metallurgy and alloys and whatnot are focused on the aerospace industry, and the mills and the primes are working very closely together on those. So then it would flow down to us. Okay.
John, I think we've gone through all the questions from the audience, and he answered them really well. So, all I can do is thanks again for presenting your slides, answering these questions, presenting a really interesting webinar here. I do want to remind, I do have another question here. I think we have time for this too. Do you provide material traceability for government-regulated projects?
Yes, and they are. I'm going to say they're cradle to grave. You can call them birth certificates, you can call them whatever, but we actually have test reports going back into the 70s on it's all scanned into our system, so we can pretty much do traceability on everything that we ship. On the warehouse floor, when material comes in, of course, it's identified in a lot of ways. When we make an order for machine-ready blanks, most of the time we'll have remnants that are going to end up back on that warehouse floor. Each and every remnant is tagged, so we know what the producing mill and lot number of that remnant is. So the traceability is pretty complete.
Okay.
Good question.
We have time. Yeah, we've got time for more questions. I don't want to jump the gun here, but unless another question comes up in our question pane, I think we've done a pretty good job of getting everything answered. So, if you do want to type another question, please go ahead. I do want to remind everyone that you can contact John if you'd like more information about machine-ready blanks. I mean, all that the contact information is on the screen. I think we're just about at the end of the webinar here. We really appreciate the time you've taken with us this afternoon, and hope you found it worthwhile. Thanks everyone for taking part. My thanks also to those who arranged the session and helped it go very smoothly. So this concludes our webinar. Have a great day, everybody. This is Mark Albert at Modern Machine Shop Magazine signing off.